In this tutorial, I will teach you how to make a clean and scalable inventory system for your game. The topics we will cover is adding items to the inventory, dropping an item out of the inventory, dragging and dropping items in inventory in order to A. Split them into two, B. Stack them onto each other, and C. Replace them with each other. So by the end of this tutorial, not only will you learn the logic behind all of these operations as well as the inventory system as a whole, but also how to implement everything here entirely from scratch on your own. So first, let us jump into the logic and then the code, because once you understand the logic, the code just becomes complementary to it. To fully understand the logic behind the inventory system, we need to first look at all of the components at play here. Firstly, we have our item. Next, our inventory, wherein we store said items inside said inventory slots. Now, if you remember from games like Minecraft, you might notice that you're able to stack some items together into one slot, whereas the others like sword, the pickaxe, etc., you are not. That means that every item has their own intrinsic value, which states that how many said items you are able to stack in one particular slot. Of course, not only the quantity, an item will have its own name, its own description, its own image, etc., etc. So let us define all of these intrinsic values of an item in a data class called item data. This is the metadata used to refer an item. Think of it as the blueprint of that said item. That is, using this we can create various instances of this particular item. Okay, moving on. Now let us assume our player wants to pick up an item. Now we cannot directly interact with this data class, or rather this blueprint. It is just an idea. What we need is the physical representation of this idea, a building made out of this blueprint for the player to interact with. So we have another component, that is the visual representation of this item data. Let us call this item, which our player will interact with. Once we pick this item, we put them into our slots. Now again, our inventory slots cannot directly interact with this data class. Same logic as the player. What we need is a UI representation of this item data that our inventory slot can store. So now we have finally another component. This is the last one, you guys can relax. That is, each inventory slot will have a inventory item component, which will store the actual data of the item being stored in this particular inventory slot. So essentially, our inventory system is just the movement of this item data class from its physical representation to its inventory / UI like representation. Once you understand this cycle, the whole inventory system just becomes a cycle that you have to implement. So repeat this portion if you did not understand it. I'm sure you will then. In the meantime, let me move on to explaining the logic behind picking up an item and then writing its subsequent code. Now, as said previously, whenever we mention that a player is picking up an item, it is just picking up a container containing the instance of an item data, filled with its own quantity and name. We then try to fit in this item data into our inventory slots, with each slot being just a container of its own item data. Now the logic to fit in this item data is actually pretty simple in paper. Firstly, we iterate through all of our slots and greedily try to fit in our item. That is, if we find a slot containing the same item as the one we want to add, we try to fit in the item into the slot by trying to fit in this item data until and unless we exceed the maximum allowed quantity that we can stack, which, if you remember, I mentioned earlier, will be unique per item and will be stored in its item data class only. If there is any amount left, we just continue our loop. If there is still some quantity left, we try to fit in any of the remaining empty slots available to us. And finally, if there is still left, we just drop that remaining quantity. Oh, and by the way, we will cover the dropping an item section of the tutorial in the next part. So don't forget to subscribe and stay tuned for that. In the meanwhile, let us now code all of our components and this item picking logic. To set the context here, I just have a basic level filled with some walls and the sun. and just a player node, which is just the template character body 3D node. Let us now work from bottom to top, that is making our item data, then the world item node, and onwards towards the inventory UI. Speaking of item data, it will be just a resource class filled with these intrinsic values: its name, its icon, the maximum stackable amount, and the description. We will then make an init function which will be used to instantiate a new object of this item data class, aka a constructor. Let's say you want to create a template item data. Let us assume wood. So to create any new item data, or rather any resource, we go to create new option and then select resource and then choose the item data inside it. Once the resource is created, we just double click it and change its properties inside the inspector, which in my case would be wood and its surrounding properties. With that item data created, let us now make a world item node. This world item node will be a area 3D having its own collision box and a mesh instance 3D, which will be used to visually represent it in the world, and finally a label 3D which will be used to display the name of the item in the world. For the code part, we first add in the reference to this mesh and the label, and then the reference to the item data this object will contain, as well as the quantity of the said item data contained within this world item node. We will provide these item data and the quantity value whenever we are instantiating this world item node into our world. The next few bits are just self-explanatory. That is, we are just setting up our world item node by updating its label, its quantity, and its item data value upon initialization. Finally, we will also need to add in a function called handle pickup, which will run whenever the player picks up this particular world item node. For all intents and purposes, whenever the player picks up this node, it should get transferred towards our inventory. That is, it should get deleted from our game's world tree. Understood? Okay. Now, speaking of pickup, let us now see how our player handles this pickup logic. Much of the next part is just an extension of my interaction system video. So I will be hand waving a little bit this player interaction stuff. So if you do not understand everything in this player side correctly, I would recommend you to go watch out that video as well to get the full picture. Anyway, moving on. We make a area 3D node called hand, whose job is to detect all of the world item nodes our player is interacting with inside this collision shape and return to the player the one that is nearest to it. For the code wise, it will look something like this. We have an array called items which will be used to store all of the world items we can interact with. Inside our getItem function, we loop across all of this array and choose the item which is closest to the player distance wise. To add in and remove items from this array, we write out that corresponding code inside the area entered and area exit functions. Moving on to the player, we add in the reference to our hand, and whenever we press our pickup button, we run through our pickup item logic, wherein we first pick up the best item nearest to us, run its handle pickup function, and add it to our inventory, which we will handle later. So let us just mark it as a to-do for now. To store items into our inventory, we first need to create the inventory item class. In theory, it can be any node. However, for the purposes of this demo, I am thinking of keeping it as a resource. Similar to our world item class, we will firstly write two variables, one to store the item data and the other to store the quantity that this inventory item is storing. We then write the constructor to instantiate these two variables. We then write the function getRemaining. This function will return us the amount of items left that we can still place inside this inventory item object by comparing our item data's max stack variable and the current quantity of items. We then add a try_add function. In this function, we will try to add in the given quantity amount of items into our inventory item object by comparing it with the remaining space left. And at the end, we return out the leftover items that we were not able to add. This function will make more sense when we wire it inside our inventory's pickup item logic. Speaking of inventory, let us write the code for that. Our inventory will be of base type node and will emit a signal called inventory changed whenever we update any inventory item inside it. This signal will be used to update our UI later on. We then add two variables, one to store the array of our inventory item and the next to store the actual length of this array. So the idea is that we are able to edit out our initial inventory size inside our editor and then just instantiate our array according to it. Next, we add in our add item function. This is the core pickup item logic of our inventory. The parameters of this function is the item data and the quantity of the said item data contained inside the world item node that is given to us by the player. Inside it, we firstly loop through all of our slots greedily, and if we firstly encounter an empty slot, we then create a new inventory item inside the slot and then try to fit in this given quantity inside the slot. If you remember, this function gives us the remaining quantity of the items that we were not able to add. So we just replace our input quantity with this. In the second scenario, if the given slot contains the same item we want to add, we then try to fit in this given quantity inside it. If after any one of these scenarios our quantity of items becomes 0, we have successfully added the item inside the inventory and then we exit out of the loop. And if not, we just continue on with this loop with the remaining quantity of items. In each iteration, we also emit the inventory change signal to tell our UI to update itself accordingly. Again, we will wire that part later down the line when we are writing the code for the inventory UI. We also need to add in one more function called getItemAtSlot. This will be used by our UI slots to get in the corresponding data of the item that they are representing. Finally, to hook this inventory to our player, we firstly add in the inventory node as its child and just add in our inventory item function in the place of our to-do. Okay guys, only two things left. That is the inventory UI and the inventory slot. Firstly, the inventory slot. Our inventory slot consists of a panel of size 64 by 64, a texture rect made to store the icon of our item data and stretched to fit the width of this panel, and finally a label anchored at the bottom right to display the quantity of the said item. For the code part, we first add in the reference to these two nodes, then two variables, one called the slot index, that is the index of the slots that this inventory slot represents inside our inventory's UI, and the second, the reference to the inventory item object this inventory slot represents. We then write some functions to set up this inventory slot. Nothing special, just your typical set item and update display functions to put in the values inside our texture rect and our label nodes. Finally, let us now jump into our inventory UI. Make a new control node and add a grid container child inside it. And just have the grid container contain 5 columns. So in short, we will have a 4 by 5 table. That is 4 inventory slots per column. Feel free to change this as well as the slot size, the slot array size, etc. as per your game. Anyway, the code is just the replica of inventory. Speaking of inventory, we first need to add in the reference to the said inventory inside this code, as that is the backend behind this UI frontend. We then add in the reference to our inventory slot and our grid container objects, and then a slots array to mimic our actual inventory slots. See, I told you before, right? This code is just a copy of inventory. Anyway, to set up this inventory UI, we run a loop using our actual inventory's slot array's size as the range. And for each iteration, we instantiate a new inventory slot scene and append it to our UI slot array and as well as the grid. We then map the inventory change signal given out by inventory to a new function called onInventoryChange, which I will define later. We then write a function to update/refresh/initialize our UI. In this, we just loop through our slots array and set the corresponding inventory slots inventory item with its corresponding actual inventory item inside the inventory using the getItemAtSlot function which we defined way back earlier. And finally, we implement our onInventoryChanged function, which is just a repeat of the previous function minus the loop. Okay guys, we are finally done. Just make sure of these few things. 1. You have added the inventory and the inventory UI inside our player node and correctly assigned all of the variables inside the editor. 2nd, you have mapped correctly the pickup item input key inside the project settings. Third, you have correctly assigned the collision masks and the collision layers. And finally, inside the test scene, you have added some dummy world items. And with all of this, we are done. What we have now is a very clean and scalable architecture behind a inventory system and a proper functioning code of picking up items inside this shared inventory. Hope you guys liked this tutorial. In the next part, I will be discussing on how to remove and drop items out of the inventory. I know this video might seem long, but trust me, this will be well worth it in the end. Anyway, in the meantime, don't forget to like and subscribe and comment to boost the algorithm. And I will catch you guys the next time. Okay, bye.